Good morning and hello everyone, and welcome back to my channel. Today is a new day, and let us continue uh, for demonstrating the subsequent stages of the MD simulation. In my previous video yesterday, we talked about how do we configure the MD simulation that involves the protein ligand complexes, and how is that we generate the files that are required for setting up the simulation, how is that you perform minimization and NVT equilibration. The subsequent stages include to equilibrate your system in NPT ensemble followed by the production run. So this is what we are going to do today. So once I open this command prompt, or what you can do, you can simply open Gromacs, and we need to change the working directory first. And our working directory is here in this test folder. We are performing all the simulations, so I will copy the task of this test folder and simply paste it over here so that we will change the working directory. Okay, now we are in the right directory. Let us make sure by hitting this dir command. Yes, we have all the files that are required. Okay, now let us get back to the Gromacs commands that we were dealing with. Till yesterday, we finished our MD simulation in NVT ensemble, and to perform NPT equilibration simulation, we will first have to configure the TPR file for NPT simulation, and for doing that you can copy this command and simply paste it over here and hit enter. Now you can see, if I sort by date modified, it has created two new files, npt.tpr and mdout.mdp. npt.tpr will contain all the information to configure and initiate the MD run Gromacs simulation for NPT equilibration. Okay, so we will talk about these two files later on. These are all about, I'm trying to uh, create a workflow that will automate these individual simulation running thing. So maybe next video we will deal with this thing. Okay, fine. Now since this TPR file is successfully created, we are good to go with the NPT stage of simulation, and we will run the NPT equilibration simulation using the Gromacs MD run command. I will simply copy this thing again. We will follow the same protocol, paste it in the Gromacs command prompt on Windows, and just hit enter. Okay, so again, protein in water simulation NPT equilibration is initiated. Now let us wait till it finish. I will stop the recording for time being now. Okay, my friends, now we are done with the NPT equilibration, and now let us see how much time it required. Over here it shows that it took 958 seconds to complete this simulation. So 958, we divide it by 60, it will give us the time that is required. That is, it took around 50 minutes to complete the NPT equilibration simulation. Well, it will depend on the configuration of your system, how powerful it is, so that this time may vary from machine to machine, and it can be different in your case. But I am using quite a bit of old PC with an old operating system that I am testing. So if it is working well at this speed, I am kind of satisfied with it, what we have developed. Okay, anyways, now let us begin, or let us proceed with the final stage wherein we will initiate and execute the production run of 1 nanosecond. For doing that, you would need this md.mdp file. It must be lying somewhere around here. Yes, md.mdp file. If you open it in textpad, uh, it contains all the parameters based on which the simulation will run. Well, for example, now we are running only 1 nanosecond MD simulations with time step of 2 femtoseconds. So it would be kind of enough to run this 500,000 steps of MD simulation for 1 nanosecond. If you want to increase the time appropriately, you will have to change this number. If you want to have different number of frames, then you might want to change some another number in this mdp file. So it will be all up to you uh, to configure this mdp file or change the content of this mdp file as per your requirement. So every time when you set up the simulation, then it is necessary that you change appropriate things over here. Okay, one more thing is that whatever protocol that I have been telling you all the way around from the last 2 or 3 videos, it is quite a general protocol. And if you keep the names as I have shown over here, you can virtually use it for any protein ligand system. So far it contains the parameters and topologies of your ligand properly, right? So this is a quite, you can say, robust protocol that we have designed. So I appreciate that it will be beneficial for you if you just keep the nomenclature that we have been using, right? You can use it for any system. Okay, now said that, we first need to create this TPR file so that we will configure the subsequent simulation that can be used by Gromacs MD Run. So to do this, we have to copy this GROMPP content that and simply paste it over here and hit simply enter. So now you can see that md.tpr file has generated, and therefore my friends, we are ready to execute the Gromacs mdrun command. This is what we are going to execute. I am copying it and simply pasting it in my command prompt, and when I hit enter, again the MD simulation of 1 nanosecond is on the way. So let us see how much time it takes, and maybe I will stop my recording. For the sake of simplicity, I have just set up and executed 1 nanosecond simulation so that I can finish this tutorial in time. So when you actually perform the simulation, it is generally advised that you perform simulations of at least 100 nanosecond. Okay, so you need to make appropriate changes in the respective md.mdp file in order to end up with 100 nanosecond or 1000 nanosecond simulation, which is standard expectation to get your data published in a very good quality journal. Okay, so please keep that in mind. For time being, I will pause my recording And here we go, the simulation is over, and it took kind of 2 hours and 10 minutes to complete the simulation. Now once your simulation is over, you can now visualize your trajectory. uh, for visualization, you are needed to open the grow file in VMD, and in this grow file you need to load the data of trajectory. uh, Maybe go to select this browse and go to desktop. There is a folder called as test, and in this test folder we would be loading this md.xtc file. Open it and just simply hit this load button. It will load the trajectory. This being only 1 nanosecond simulation, there are only 102 frames. Let us try and see if everything is fine. Let us create a good representation, and in this representation, for example, let us first select only the protein molecule and create a separate representation for it. Let us delete this previous representation so that we can only focus on protein now, and let us create another representation for the ligand molecule, which can be identified in your VMD by residue name. We know that throughout the simulation procedure, the name of our ligand was like this lig. So double clicking on this lig and double clicking on this res name will get the selection in the selected items menu shown over here. So once you have made the right selection, then you can hit this create representation button. Okay, and now we have selected everything. Now it's time to show the protein in new cartoon representation. Okay, and let us show our ligand in whatever is your favorite thing. Let us check it out in vendor wall. Okay, so once you have done this thing, you can adjust the speed of your trajectories from this meter over here. Let us keep it like this. Maybe zoom in it a little bit and just hit this play forward button, and now you can see how beautifully your protein starts to move in the MD simulation. You can see how is that your ligand reorients itself in the binding site, so on and so forth. Now you are ready for the subsequent step, like calculating the parameters that are required for analysis, like RMSD, RMSF, radius of gyration, maybe perform binding free energy estimation using MMP BSA or perform PCA. Now you are ready to do such an analysis. Well, this is one thing that you can do. What we have done from our lab is that we have now generated the graphical user interface of this Gromacs. You can move on to that playlist, wherein I have demonstrated how to use that graphical user interface and what are the features for trajectory pre-processing, trajectory analysis. So I think that might be the next stop for you. Okay guys, so see you in the next video.